What does 1 barrel of crude oil actually become? A lot of people know that crude oil turns into fuel, but that answer is only the beginning. 1 barrel of crude oil does not become one thing. It becomes a spread of products that move through modern life in very different ways. Some power cars, trucks, and aircraft. Some help make roads. Some become chemical feedstocks for other industries. Some remain as heavier industrial products. So to understand this properly, it helps to stop thinking of crude oil as one dark liquid that simply turns into gasoline. A clearer way to understand it is to see crude oil as a mixture. It contains many hydrocarbons with different properties, and the refinery's job is to separate that mixture, upgrade parts of it, and turn it into useful product streams. That is why the story of 1 barrel is not really a story about one fuel. It is a story about a whole system. Let's start with the barrel itself. In the petroleum industry, a standard barrel of crude oil is 42 US gallons. That unit gives us a useful frame. If 1 barrel goes into a refinery, what actually comes out? The first important point is that there is no single universal answer. The result depends on the type of crude oil, the design of the refinery, and the product demand in the market that refinery serves. Lighter crude oils generally contain more light hydrocarbons, which makes it easier to produce products such as gasoline, diesel, and jet fuel. Heavier crudes contain more heavy fractions and often require more complex refining. So any clean breakdown should be treated as a reference example, not a rule that applies identically everywhere. With that in mind, a useful reference comes from average refinery yields in the United States. From 142-gallon barrel of crude oil, U.S. refineries on average produce about 19 to 20 gallons of motor gasoline, about 11 to 13 gallons of distillate fuel, and around 3 to 4 gallons of jet fuel. On top of that come smaller but still important amounts of liquefied petroleum gases, petrochemical feedstocks, lubricants, asphalt, petroleum coke, and other products. That already changes the picture. 1 barrel of crude oil is not mainly a story about one end product. It is a portfolio of outputs. And to keep that portfolio understandable, it helps to think in broad layers. Lighter products, middle products, and heavier products. The process begins with separation. Crude oil is heated and sent into a distillation tower. There, the refinery first separates components by boiling range. Lighter fractions move higher in the tower, while heavier fractions remain lower. This first stage does not yet finish the job, but it gives the refinery a structured starting point. Modern refining, however, goes beyond simple separation. Refineries also convert and improve lower-value fractions through processes such as cracking, reforming, treating, and blending. In other words, the barrel is not only sorted, it is also reshaped. That is how a refinery can turn more of the barrel into products that meet fuel standards and match market demand. This is why transportation fuels make up such a large part of the story. Gasoline supports passenger vehicles in many markets. Distillate fuels, especially diesel, support trucks, buses, logistics, machinery, and in some regions heating as well. Jet fuel supports aviation. Even before we look at the rest of the barrel, one refinery input is already helping support road transport, freight movement, and air travel. But the barrel does not stop there. Part of refinery output also goes into the petrochemical system. This is an important point because crude oil is not only about fuels that get burned. Some refinery products become feedstocks used further downstream in the chemical sector. These help support materials such as plastics, solvents, synthetic fibers, and many other industrial or consumer products. The chain is longer than a simple one-step conversion, but it is still true that part of the barrel enters the chemical side of the economy, not only the fuel side. At the heavier end, the picture changes again. Some material can become asphalt or road oil. Some can become lubricants that reduce friction in engines and machinery. Some ends up as petroleum coke or other residual products. These outputs are not always the most visible to the public, but they are part of what makes crude oil an industrial raw material and not just a transport fuel source. There is also one detail that often surprises people. In U.S. refining, one 42-gallon barrel of crude oil can yield about 45 gallons of petroleum products. That sounds impossible at first, but the explanation is refinery processing gain. The refinery is not creating matter out of nowhere. What changes is volume. When denser hydrocarbons are processed into lower density products, the total liquid volume can increase. So the output can take up more space even without violating physics. What matters in real life is not only what can be made, but what the refinery is trying to maximize. Refineries respond to economics, regulations, seasonal demand, available crude supply, and product standards. That means the product mix can shift over time. The story of one barrel is therefore not only chemistry. It is also a market and system story. So if someone asks what one barrel of crude oil becomes, the clearest answer is this. It becomes multiple product streams. A large share goes to transportation fuels. Some supports aviation. Some enters petrochemicals and chemical manufacturing. Some ends up in heavy industrial uses such as asphalt, lubricants, and petroleum coke. The exact balance varies, but the core idea stays the same. One barrel of crude oil is best understood not as one product in waiting, but as a structured industrial input. It enters the refinery as a complex mixture, passes through separation and upgrading, and leaves as many useful outputs that support transport, infrastructure, manufacturing, and daily life all at once. That is the real picture behind a single barrel.